Hello, Algebra 2! I have some exciting news for you. I am using my document camera. I finally got it approved, and now hopefully your videos will go really well. And I even set it up myself, so we all know that was the most challenging part, but we're here. And this week is the unit circle. So the unit circle is really important for some things we're going to do in the rest of this chapter or next chapter, but also next year it'll be very important. The unit circle, I usually do that in 2 days, and so I'm going to make a couple different videos for this. So we are going to start by talking about what a radian is. So the official definition says it's a unit of angle measure based on arc length. A really good way to think of it is in terms of measurements. So like for temperature, right? In temperature, what are different ways that you can measure temperature? You can measure it in degrees Celsius, you can measure it in degrees Fahrenheit, you can measure it in kelvins. Okay, for angle measures, we are used to measuring it in degrees, but the other way that you can measure it is in radians. So that's what we're going to talk about today. So 180 degrees, which would start here. Remember, this is 0 degrees. Okay, this would be 0 to 180. And 180 is equivalent to pi radians. Okay, so that's your conversion rate. 180 equals pi radians. That means if you were to double it, 360, if you double pi, you would get 2 pi radians. So we are going to use this conversion rate to help us go back and forth between these. Okay, this is all based on the circumference of a circle. So if you remember from geometry, the circumference is 2 pi r. And then if you do an angle representing one complete clockwise rotation is going to measure 2 pi. Okay, so that would be one time around the circle. And then we know that 2 pi is equivalent to 360. So when we are converting from degrees to radians, if you guys have been in in chemistry, you probably already did this where you were converting units. So if you had pi radians, if you have degrees, you'd want to multiply by pi over 180 degrees. Okay, and then if you are going from radians to degrees, you would multiply by by 180 over pi. All right, so if you started with degrees, you'd want it to cancel out. That's why it's on the bottom. Here, if you started with radians, you'd want it to cancel out on the bottom, and that's why you have pi. So we are going to do some conversions. Now, when you are converting, if there is a degree symbol, it means it's in degrees, but if there's no degree symbol, the unit is in radians. Most of the time, the radian is going to have pi with it, but it doesn't have to. And that is something you'll study more next year when you are in pre-calculus. And really, if it doesn't contain pi, it would just be a decimal. It would just be like 3.14. Okay, so we are going to convert negative 60 degrees, 250 degrees, 2 pi over 3, and negative 7 pi over 2. So if it is in degrees, then we are going to multiply that by pi over 180. And then what happens is, if you have a unit on the top and the unit on the bottom, those cancel each other out, and that's why you're left with the radian value. All right, so really what we're doing here is we're just reducing this fraction. When you multiply a fraction, this just becomes negative 60 pi over 180. Divide by 10, we know that 6 goes into 18 3 times. So this would be negative pi over 3. Okay, so 6 over 18 reduces to 1/3, and then you just don't need to put the 1 because you have the pi there. Okay, for B, again, we'll do something similar. So we have degrees, so we're going to multiply by pi over 180, and then really we are just simplifying that fraction. So we know that we can divide them both. Here we'd have 25 pi over 18, and then can you reduce that fraction any further? Nope, there's no number that goes into both 25 and 18, so that is going to be your final answer in radians. Okay, when you are given the radians, again, you'll know it because you don't have the degree symbol, and that means your final answer for degrees, you do need to put the degree symbol. Okay, and sometimes you might even see it. It might even say 2 pi over 3 radians. Sometimes it might say that. And then we're going to multiply now by 180 degrees over pi. Okay, so what happens here is the pi's are going to cancel out. I'm just going to write this as a fraction first. So if I just multiply straight across, 2 times 180 is 360. So I have 360 pi over 3 pi. And 360 divided by 3 is going to be 120. My pi's are going to cancel, so I have 120 degrees. Okay, so you need degree symbol here. All right, and then similar process with this one. We're just going to multiply by 180 over pi. Okay, we do know that the pi's are going to cancel out. You could also just start reducing here right away. Like I know that 180 divided by 2 is 90. So if I did 7 times 9, that would be 63. So I'm going to put the 0. This was negative. And then the pi's also canceled out. And negative 630 is my final answer. All right, so the unit circle. We're going to talk a little bit about this, and then we are going to make the unit circle. And that is probably the most important part, is making the unit circle. Sometimes people try to memorize the whole thing, but there's lots of cool like tricks and patterns to help you get it down. One thing we want to point out is that a unit circle is going to be a circle that has a radius of 1 unit. So the radius of the unit circle is 1. Okay, that is always the case here. The radius is 1. For every point that is on the unit circle, the value of r is 1. That means that for every angle theta, we are going to set up a couple of equations here. Okay, so it said the value of r is 1. So let's think about this. We learned that the sine of theta is equivalent to y over r. But if the value of r is 1, if I plug in 1 here, I have y over 1, which is just y. What that means is the sine of theta is equal to y. For the cosine of theta, remember that that was x over r. So if I have x over 1, that would be x. So we can say the cosine of theta is equal to x here. And then the tangent is y over x. Okay, but if the sine is y and the tangent is x, then we know that the tangent is also the sine of theta over the cosine of theta. Okay, so when we talk about the points on the unit circle, every point that is xy actually represents the cosine of theta and the sine of theta. Okay, so we are going to have points on the unit circle that are going to represent cosine and sine. All right, so after this, you should be making your unit circle. Okay, and then after that, there'll be one more video that just shows how you use the unit circle.